Hello, my name is Rabia Farouk, and this presentation is all about my personal reflection about what I am taking away from this course, and also some of the approaches which I think would be appropriate to introduce Einsteinian first in my own classroom. Um, I have provided my email ID so that if you have any questions, you can ask me. I would love to answer the questions. So let's start. Introduction. Einsteinian is considered the father of modern day physics, and his concept of relativity and quantum physics brought a revolution, and we benefit from them in our everyday life. So introducing the Einsteinian's concept to primary school students is a great initiative. This is what I think, and will build a base for students to comprehend the new ideas of space, time, gravity, and quantum physics. So Newton's physics is taught at various levels in the Australian curriculum. However, with the evolution of science, it is imminent to introduce young kids to the latest concepts so that they know the universe, and this should be done by developing activities designed for their level and which are customized to them, and something which doesn't make it boring but good for them. So the question arises, why so early? I have put some researches over here where the teachers are saying that introducing science concept to primary students is good for their brain. And then I have a link over here which shows that implementing Einsteinian first had a really good impact on students' brains and learning. This is a graph which shows the contribution of Einstein when key events in the history of physics took place. The Einsteinian revolution. This mainly covers the discoveries, concepts, and ideas of Einstein, his contributions and contradictions over the concepts of other scientists. All this led to uncovering things like heat as jiggling atoms, universe has a speed limit, gravity cannot be felt while falling, and then big numbers, probabilities, building blocks of matter, explanation of gravitational waves, and spooky actions at a distance leading to quantum computers. Now I would like to say something about that what I understood from Einsteinian first. So the Einsteinian first project aims to redesign, evaluate and optimize school science across all educational levels to reflect the modern understanding of space, time, matter and the universe. And it began by developing innovative methods for teaching school-age children the concept of Einsteinian physics. And then Einsteinian first is creating an evidence-based curriculum that takes students on a journey of modern discovery instead of the old ideas, which are mostly not, some of them are not accepted these days. So Einsteinian first project uses interactive learning model, and the curriculum resolves the disconnect between science in school and science of the modern world. Teaching with toys, models, activities using predictions, testings, measurements, graphing include math concepts like maths of small and huge numbers, chance and arrows. Use of models and analogies to introduce conceptual thinking. So, Ellen Simon said that science doesn't stop moving, or curriculum must also keep up with the times. And after taking this unit, I believe in that because these are some ideas which are which can be like maybe a pathway to a new horizon. So Einsteinian first learning model It involves visiting a topic at deeper levels to enhance understanding. So, why Einsteinian physics or Einsteinian first? As a pre-service teacher and having exposure to primary schools in Western Australia, I have come across some problems which the schools are facing nowadays, like students should not be kept away from difficult topics in the early years of their brain development. Instead, they should be introduced to conceptual understanding. And then education is made easy in primary, but it gets difficult in secondary. So there is a gap of learning for students in between, whereas it should be consistent. Then understanding the universe at present is very important. And for this, to introduce students to physics concepts which are true till date, it is very important. Instead, first they learn the old concepts and then they learn the new concepts, which is going to confuse them. The idea over here is not to start like teaching small children with the highly complex content of like theory of relativity, quantum computers, and equals to mc square type of equations and scare the students to come to school. It is simple thing that to set the correct path for concepts of science, physics, which they are going to deeply explore later in the curriculum. So, like teaching the concept of light with photons, talking about heat along with jiggling atoms, telling time as a relative entity, introducing space as stretched curved fabric instead of a flat surface. Doing so will set the base for correct concepts of physics, which are nowadays introduced at later stage in education. So most of the students are unaware of the working and understanding of the universe if they do not choose like physics as a specialist subject, or if they choose some other learning areas like arts or anything else. I believe if the base is set correctly in primary, then the students can be introduced to secondary Einsteinian concepts with ease. And the ideas won't be like alienated concepts to them, which are too difficult. Instead, they'll find it interesting and engaging. These are some of the foundations of Einsteinian physics, Einsteinian first, which I learned and I'm taking away from this course. What is a photon? Einstein explained that in physics, a photon is a bundle of electromagnetic energy. So how do we show this as an activity in Einsteinian first is given in the next slide. This is an activity of photons where students photographing each other with a photon gun. This is how Einsteinian first introduces concepts to students, which is engaging, and this is an effective learning environment where everybody learns. The slide shows information about photons, which is given in Einsteinian first. As you can see, this is simple information which could be easily explained to primary using visual models, and this would be explained later in the presentation. What I did over here is the activities are taken from Einsteinian first project, and then I wrote that how I am going to introduce these into my lessons, like using slinky models can be integrated into math measurement lessons, then using nerf guns can be used into as integrated into math lessons, and like introducing the concept of amplitude, frequency, wavelength. This can be an art lesson or a science lesson, even math lesson. Box activity for how we use photons to see objects. This can be an art lesson. But as the teacher uses the vocabulary and the understanding of the physics can like play an important role into making the base of the concepts in primary. My ideas and approach for introducing Einsteinian first into my own teaching practice. I have few ideas like integrated plans, um, making science lesson with models and analogies. Weekly news topics may regulate around the concepts of Einsteinian physics. Then we have classroom vocabulary, especially during playtime, fun times. For example, what are the binding forces between two blocks of Lego? This type of ideas can be introduced. If students are not offered the complete complex high level concepts, they can be given the vocabulary, the introduction, definition of smaller concepts from the complex ones. So big numbers and small numbers can be introduced using Lego, animated videos, book reading. And then we have introduced straight lines using basic activities, which can be in the playground. Introduce dimensions like 2D, 3D, 4D. These are all the parts of the activities which are introduced in Einsteinian first project. So then we have introducing the idea of space-time linked together with the example of meeting a friend. So uh, using hands-on activities, using gradual release of responsibility concepts for younger students like year 1 or 2, role plays using books, power of twos and power of tens can be introduced using chess activities, extension of multiplications, vectors should be introduced using maps like Einsteinian physics integrated with geography, and estimation of and probability can be introduced in lessons with coins, making Einsteinian physics stations in the classroom using posters, toys, instruction for the students. Then at school level, teachers should be trained for the Einsteinian first project implementation. Then science without practical is swimming without water. So Einsteinian first project is based on the hands-on activity. So then creating activities for the concepts and ideas to make it easier for understanding, and then breaking the bigger concepts into smaller ideas, like the idea of straight lines can be explained in the playground as shortest directed distance between two students. These are some of the ideas and approaches which I'm going to use in my own classroom. And I would also like to mention that I tried to reference all the images used in this presentation. Also, the quotations and information in this presentation is referenced. I would love to answer all the questions which you would have. You can email me and you can find the email at the beginning of the presentation. Thank you so much.